A multi-stage experiment could consist of multiple different experiments consecutively. And we often use tree diagrams or set notation with multifaceted elements to describe such experiments. So let's look at example 2 from the packet. It says, consider rolling 2 6-sided dice. Draw a tree diagram. What is the cardinality of the sample space? And list the event consisting of outcomes where the dice add up to at least 8. So let's just start off with creating a tree diagram. So we can imagine rolling 2 die consecutively. And since we've already listed the sample space, obviously there's 6 outcomes. You could get 1 through 6. And so, we could always start off with a tree diagram saying, well, these are our outcomes for the first roll. And then we have another roll consecutively where we could draw out, stems from each of the first outcomes leading to the second outcomes. And obviously on the second outcome, you could have a 1 through 6 as well. So from the first roll, I could get 1, 2, 3, 4, 5, or 6. And, I could write those all out as acceptable outcomes. And then if I rolled a 2, same sort of thing. And as you can see, I'm going to run out of space here. But we can just use the tree diagram to help us visualize what would happen. And of course, I'm going to have 6 outcomes stemming from 2 as well. 1 through 6. I would have 6 outcomes coming from 3. And so forth. And so I could then count up the total number of outcomes by looking for the final stems of each of those tree diagrams. So, in that case, I'd have 6, 12, 18, and, basically each original number leads to 6 more numbers. Or if you recall the fundamental counting principle back from the first semester, what that stated is that if we have 2 separate events, each of which had n outcomes, or the first event had m outcomes, the second of which had n outcomes, the total number of outcomes is always equal to the product of the number of individual outcomes for those. So like in this case, since we had 6 outcomes from the first, the event, and the second event was the same thing, or the second sample space, was the same thing, 6, we're going to have 6 times 6 total outcomes, or 36 at the end of the day. And, we could write out the sample space for this experiment as, since it's more than one thing, you could write it in the form like 1, 1, 1, 2. For numerical answers, this is not really proper notation because it looks like the number 11 and 12, which are not the same as consecutive integers. So what's a little bit more common, I won't say more common, but a little bit more proper, I suppose, would be listing those events using separate parentheses. So like I could do parentheses 1, 1. And what that would correspond with would be, say my first die, I roll a 1, then my second die, I roll a 1. That is one potential outcome in this multi-stage experiment. Or, I could have rolled a 1 first and then a 2. I could have rolled a 1, then a 3. I'm sorry, my dog really wants to play right now. He will have to wait a little bit. He's distracting me. And so forth, right? But, by kind of the fundamental counting principle, we're going to have 6 times 6 potential options, which would lead to 36. And, that trend would continue. I'd have 1, 1 all the way up to 1, 6, 2, 1 through 2, 6, and so forth, all the way till I get to, 6, 4, 6, 5, 6, 6. So I'm just going to use the ellipses here in my set to sort of imply, well, everything in between 1, 1, 1, 2, 1, 3, all the way up to 6, 4, 6, 5, 6, 6. And again, the cardinality, remember, that's just another term for how many objects are in the set, which we use the notation n parenthesis s to describe, what's the size of the sample space, but that would just be, as I said, it would be 6 times 6 by fundamental counting principle, or 36. And that's really because each individual sample space had 6 elements, and the number of a multi-stage experiment would be the product of the cardinalities of the individual spaces. And then the last question, or the last thing it asks us to do, is it says list the event consisting of outcomes where the dice add up to at least 8. So considering a lot of these outcomes, some of them you can see, like say I roll a 6 then a 5. or a 6 and a 6. Each one of those, the sum of the dice is more than 8, or at least 8. Whereas some rolls 1, 1, 1, 2, and 3 is not 8. And so we could distinguish and say, there's a specific event that is a subset to the larger sample space. So we have like the entire sample space, which consists of 36 things. But we could then look at a particular set of outcomes, the event consisting, of the cases when they add up to at least 8. So we could just, if you're wondering how do you come up with this, you could just start listing them, and I would follow a very procedural approach. Like, what you could do is look at each of your stem and or each of your connected parts of your tree diagram to see which ones add up to 8 or more. And like, if I start with 1, none of those are going to add up to 8, right? Because even if I go 1, 6, that only adds up to 7. But once I go down to the 2 branch, if I start with 2 and then go to 6, so let's just call this E2 for the set of events, since we're working on question 2 here, and actually we're going to use this in a later video, which is why I'm going to use this naming convention now. And I'll go ahead and call this S2. I don't remember if it matters, but just in case. So one of our acceptable outcomes here would be 2, 6, because that would be an outcome consisting of 2 dice roll which add up to at least 8, and that would be the only one from starting from 2. Now, if we started from 3, 3, 6, but 3, 5 would also work. So we actually have 2 options starting with 3. And you can think about this in a very procedural process. Like, if I start with something, what are the next possible outcomes which satisfy these particular conditions? And in this case, if I start with 2, there's only 1. But if I start with 3, there's actually 2 acceptable ways to make 8. And, as I increase the first roll, it means there's more options for the second roll. Like, say I start with a 4, I could either have a 4, 5, or 6. All of those would add up to at least 8. So 4, 4, 4, 5, 4, 6 would all be fine. And it's just going to keep increasing as I go to the first roll. Like, if I start with 5, either 3, 4, 5, or 6, any one of those would add up to 8. And so I'm just going to form a process, like by process of elimination, or by literally looking at every possible outcome, I could weed out the ones that make sense and the ones that do not. And then starting with 6 as well, 6, 1 will not add up to 8, but 6, 2 and anything higher will. So I would have 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. And that would be my event that was asked of me, basically consisting of every possible outcome that adds up to at least 8.